Good afternoon, Growsmart family. I am Suanne Rampou. I will be taking you through the science launch for 2021 in collaboration with my colleague, Ms. Zuki Kala. We want to welcome all of you this afternoon, and we hope to take you through a journey of science. Especially, we want to welcome our family from the Eastern Cape, who is joining us for the very first time.
Hello, I'm Jewel Harris and I'm the founder of Growsmart Educational Program. Our program started in 2010 when we started off with just a literacy competition, and I cannot believe so many years have passed where we have completely evolved to being an educational program. When we started way back in 2010, we were just a literacy competition aiming at grades 4, 5 and 6 learners, and all we did was spell this word, define it, and use it in a sentence. Well, lo and behold, here we are so many years later, and we do so much more. Our program has evolved to cover story writing and poetry. In fact, we have several authors under the age of 13 who are published, and those published books have been redistributed to our Growsmart schools. We also include mathematics, science, debating, and we have recently introduced entrepreneurship. Our debating and entrepreneurship is for our grade 6 learners. So not only do we run these programs, but the best thing is that actually all the work that we do is curriculum based. That means there's no additional work for any teacher in the classroom because all the work that we cover is already covered in your classroom. But what we do is ensure that everyone has fun with our digital program that we are now launching this year, and all our material that we use. Absolutely everything is done to encourage the child to have fun while they are learning. So not only have we expanded our program over the years, but also we have taken our program to various provinces. So we partner with the Western Cape Education Department, the Eastern Cape Department of Education, and also the Limpopo Education Department. So such a pleasure to actually partner with the education departments and bring about change in education. Our program has also started a bursary section. So our learners who make it through to our various competitions, and from semi-final round, we open up the doors and introduce them to our bursary partners. And through that, they are able to apply for high school bursaries. But we didn't stop there. Since then, we've actually managed to place several students in university and watch them grow through the various degrees that they are doing, such as medicine, politics, and various sciences. So an absolute pleasure to know that we have taken a child from primary school through high school and then onto university. So Growsmart is really bringing about change, and what an absolute pleasure for us to be able to do that through Growth Point Properties. Watch this space and watch us evolve and partner and grow throughout the years and bring about change. We are Growsmart Educational Program. Thank you. Hello, I'm Jewel Harris and
Right. We are going to get ready to start the project. We will take you through the steps of how to do a science project. We expect our learners to have passion for natural sciences, to have ideas, to learn by doing, and to get ready to execute their projects. Choosing a topic or a question, ideas for a good topic may come to your mind straight away just by debating issues that bother the learners from their communities. Ideas for projects can also be obtained from newspapers, magazines, articles, the internet, television programs, etc. Brainstorm possible topics. To begin with, jot down every interesting project or idea that comes into their mind. They shouldn't worry whether they are realistic at this point. That part of the process will come later. A background research for each topic to narrow down the list is very important. Determine clear and concise objectives for your project. Develop a research plan with possible testing methods. Make a final topic selection. Review their research plan with their teacher. Now, clarify the project requirements. The best projects are not always complicated, but are imaginative and well completed. A good project is often a clear solution to a problem or a new idea for a piece of apparatus. A need to clarify the project requirements. Be original. Do not choose a project that could be dangerous to yourself or to others, that needs any experiments on insects, animals, or humans, that involve collecting plants or animals that are protected by nature conservation laws. If there is any doubt as to whether the topic will make a suitable project, ask your teacher for advice. Seek inspiration. The internet is full of good resources for science project ideas. However, do not just copy someone else's project, especially when yours needs to be original. Do not repeat an experiment from the school syllabus or choose a project to which people already know the answer. For example, in natural sciences, we have the topic, does temperature affect the rate of dissolving? This will then not be a Growsmart project, as the procedure to follow is well known and the answer can easily be looked up in any school textbook. Why not work with your science buddy? Start thinking practically. At this point, it is not easy, not simple as asking which idea you like best. Instead, you have to consider questions like, can I turn this idea into a project that I can finish in time allocated? For example, if you have 3 weeks, you can make growing tomatoes from seeds out of your project. Secondly, do I have the skills and resources to transform this idea into a project? For example, building a computer from spare parts is not for everyone. And thirdly, will I have the patience and the perseverance to turn this idea into a project and see it through the end? After all, good ideas do not always translate into projects. It is doable. Can you answer the problem question? What are you going to measure to complete your project, to collect data? What instruments are you going to use? In what units will the measurements be taken? Will you be able to document your answer? How would you find your answer? What will your experiment method be? What materials will be needed and how much will they cost? Is there any part that will be unsafe or dangerous when you are doing your project? Will you need as adult supervision? Is this too basic or too complicated of your question for someone of your age? Most importantly, is your question interesting and original? Now, once you have brainstormed all those questions, you are going to go to your next step, which is completing a research plan. Learners must compile a research plan for approval before starting the project. The length of a research plan should be between 2 to 4 typed A4 pages. They should give their research plan to their teacher or mentor for approval before starting the project. At that time, the ethics should be taken into consideration. Now, what is the content of your research plan? The research plan always answer the following questions. What are you going to do? That is your introduction, your problem statement, your aim, hypothesis, or technology goals. How are you going to do it? That will address your method, including ethics. When are you going to do it? That will be include your time frames. What information do you need before you start your project? That means you need to research. You will need the bibliography of at least 3 relevant sources of information. Who is going to check that your project can go ahead? Obviously, that will be your teacher or your mentor. Where to keep your research plan? We highly encourage that you use your Google Drive and a printed copy goes into your journal. Very, very important to keep those records. Right, let's talk about preparing a research plan. Projects fail if learners lose interest or can't stay motivated during the preparation process. Hence, worry less about what will impress the judges and more about what will interest the learners. If learners can't enjoy the project, the odds are good that they won't enjoy doing it either. Now, your research plan headings, relevant to all types of projects, especially in the natural sciences and technology. The first part will be your problem statement. What problem are you addressing? Then you are going to address the aim. What do you want to find out when you do this project? Now you are going to state your hypothesis. This is a statement or a claim about something that can be tested in some way, and it should be measurable as well. Your research will test the hypothesis to accept or reject it, or to see whether it is correct, incorrect by doing an experiment. A poorly formed hypothesis is difficult to test. Your hypothesis must be clear, simple, and testable. We will start with the technology process for those young scientists whose minds and passion are in technology. What is the primary goal you want to achieve with your prototype, your design solution? Your goals will help you to test the functionality of your design or your solution. What methods and materials are you going to need for both the scientific method as well as for technology project? You will need to write down your procedure, obviously, and describe the details, the method or the procedures you will use. And this will answer the question you have asked to solve the problem or to test the hypothesis. Or it will take you through the steps to be taken for a design and procedure. Your first prototype, that is in the case of technology project. In addition, how many trials you will conduct. Do not include work done by someone else without acknowledging their work. Work done by a university lab or work done prior to your involvement in your project. Your project title. It must reflect the topic and must be written in a form of a question. For example, do plants need water to grow? How does caffeine affect growth of a plant? Does exercise make your heart beat faster? You can see all those needs to be measured and data needs to be collected. Time frames, very important. When? This is your project work. From the first day you start your project until the date of the submission. Write down the dates when you think you will be doing each and every of the above steps, including your literature review. Please note, you will need to complete your project at least 1 week before the due date for online submission so that you can do final check of the research plan and report, and also mentored by your teacher. Now, establish your project type. We have learners who will be interested in the design technology process, and some learners will be interested in the scientific investigation. For those learners who are going to follow the design process, it can generally be summed up by the following steps: identify the problem, raising questions, investigate possible solutions, choose a possible solution, design, build, and test your prototype, and evaluate every step of the process. And if it does not meet the requirements, you will need to redesign, rebuild, and retest until it meets the technology goal. That is just a summary of your design technology process. And the learners must practice that this is a cyclic process. Very important when we look at the design process that the learners need to write down a design brief. This will tell people what you are proposing to do or to solve. You need to write down your specification and constraints. Please list all those specifications, how you are going to solve the problem. The materials and tools that you are going to use, write down a list of them. You need to make sketches, drawings, to show possible designs for the solution or the problem. Remember, you need to choose one of these designs, then you need to work with drawings to solve a problem, and make sure that you keep these designs as part of your evidence. The judges will compare your initial plan of your design to what you actually made to see how well you address the problem and that you have identified. For those who are going to follow the scientific method, we will follow identifying a problem, gathering a research information, formulating a hypothesis, designing an experiment to test our hypothesis, recording and organizing data, analyzing data, and drawing conclusions. Use conclusions now for a new hypothesis if there is a need for you to repeat your experiment. Variables. This is a very challenging languages to our learners. We have got 3 types of variables that we address when we do the scientific method. We have what we call an independent variable. This is what we change during the experiment. We have a dependent variable. This is what responds to the change or what we are going to measure. And then we have the control variable. This is all those variables we are going to keep the same to ensure that our test is a fair test. It will not change value to what we measure. The new value of the dependent variable is caused by the and depends on the value of the independent variable. Remember, your dependent variable is what you are going to measure during the investigation. Repetition. Every experiment, the investigator must repeat the test process not fewer than 3 times to be assured that the results are consistent. Now, every learner doing science needs a journal. All scientists keep a written record of their observation in some form of a journal. This is the journal entry should begin with the date and the time the experiment collected the data. If important to the experiment, data will include also environmental values such as the humidity and the temperature. Remember, this can easily affect what your hypothesis plans were. Entries must be written clearly and with detail of descriptions so that another scientist can read the journal, simulate the conditions of the experiment, and recreate the experiment exactly as you intended. Now, in developing your project, start with fresh ideas as a purpose or problem statement. We have indicated that earlier. Research what is known in literature. Develop a hypothesis, design an experiment, test and collect your data, analyze your results, make conclusions, and complete a research report. You will get a template regarding a research report. Right. The template shows how you are going to write a research plan. For the scientific method, you have got the steps that you are going to follow. And for the design technology, you have got the steps that you are going to follow. You'll get the details of that information later.
Good afternoon, everybody. Zuki Gala is my name. I'm gonna take you through the ethics. Learner ethics and safety checklist involves what is right or wrong, what is good or bad, fair or unfair, responsible or irresponsible. So learners are expected to consider ethical rules and regulations for both conducting the research and exhibiting all the levels of Growsmart competition. What's the purpose of this checklist? is to ensure that all projects that are submitted for assessment do not violate ethics. So mentors need to coordinate the ethic check and approval process so that no project is disqualified. The research involves breaking of any of the country's laws. Examples: human testing, animal testing, health and safety, written and visual violations. With human testing, where humans are used as subjects for testing or their interactions with humans, ethical violations occur when the physical or mental well-being of the subjects are put at risk when testing is done. For animal testing, animals must not be subject of testing. No testing, no physical harm or physiological disruption, and no interference of their natural habitats. Health and safety, any testing involving substances, equipment, methods or processes that put lives of the researcher or participant or the environment or in the environment at the risk are ethical violations. Written and visual violations occurs when words, text, and ideas are copied, or information obtained from books, articles, newspapers, websites are not cited or referenced by the learners in their work. Images like pictures or graphics or photographs that are not acknowledged. Or failure to cite or reference sourced information is called plagiarism. Violation also occurs when images displayed are offensive and insensitive, causing discomfort. Now, when it comes to brand versus objective labeling, brand names should not be used. Instead, use objective labeling like brand A or brand B or brand C. Now that's about ethics, Growsmarters. We wish you good luck. Now I will refer you to page 42 to 53 for more detailed information regarding the Growsmart Science Competition. There are prizes to be won as we look in the screen. That the third prize, learners, they will win 5,000 Rand towards their education. Mentors 3,000 Rand for shopping vouchers. The second place is 10,000 Rand and the mentors 5,000 Rand. And the first prize is 20,000 Rand towards the education, and mentors 10,000 Rand for shopping voucher. But no cash will be received.
Growsmarters, thank you for a wonderful afternoon that you have shared with us. We would like you to follow us on our various social platform media, such as our Facebook, our YouTube channel, our Instagram, and the Growsmart website, www.growsmart.org.za. We wish you good luck. Have fun doing science. We are looking forward to evaluate and choose the best scientists for 2021. Thank you.